Hello and good day to everyone. My name is Muhammad Yazid bin Muhammad Sufyan, metric ID VA23007. Today I'll be presenting about the introduction of the industry of our project on the Pars Oil and Gas Company from Iran or POGC, focusing on the industry background, assumption and products derived from the facilities. Uh, so let's begin with the industry background. The oil and gas sector is crucial globally, and in Iran, POGC stands as a major player. They're responsible for exploring, extracting, and processing hydrocarbons. Their facilities are highly advanced, incorporating cutting edge technology and strict safety measures. POGC operations aren't just about production, they emphasize in efficiency, safety, and environmental responsibility.
After Russia, Iran holds the world's second-largest natural gas reserve. Iran and Qatar share a crucial area in the Persian Gulf, particularly the South Pass and North Dome field. The sector is controlled by the state and is impacted by geopolitical tension and change in the world market. The Pars Oil and Gas Company (POGC), a division of the National Iranian Oil Company (NIOC), was founded with the purpose of developing, managing, and operating gas projects, including the South Pass gas field, one of the most important natural gas stores in the world.
So let's start off with our first thing, which is the project's objective. The project aims to demonstrate how a typical POGC facility undergoes a commissioning, that is getting up and running, and how it's safely shut down for maintenance, a process known as turnaround. Our primary goal is to simplify these complex processes into a clear, understandable steps, providing a straightforward roadmap for safe, reliable, and efficient plant operations. Uh, by thoroughly documenting each phases, we hope to support better planning, safer workplace, and a smoother handover for future engineers and operators. Moving on to the scope of our project, we aim to cover several key areas. First things first is a brief overview of the oil and gas industry, specifically focusing on POGC operations. Next is an explanation on the main products and their production methods using an actual PNID from a POGC plant. And then we'll look at the objective, boundaries, and assumptions behind the typical plant turnaround. We also outline the teams and job scopes involved to ensure a smooth operation, and then a step-by-step guide to project management during a turnaround and commissioning will be presented. And finally, a comprehensive risk assessment to highlight the potential hazards and how to address them. As for the next highlight, which is the assumption and constraints, just like any real world project, we have made some key assumption and acknowledge certain limitation. First things first is we are using a standard POGC facility as our model, meaning some details are generalized. And then all safety and process system are assumed to meet international standards. And the last thing is our focus throughout the project is on minimizing the downtime and maintaining safe and environmentally friendly operations. And finally, let's take a look at the main products from a POGC facility. And as depicted in the PNID, it includes the first product is the stabilized condensate. Stabilized condensate is a high value liquid hydrocarbon separated and treated for storage and export. The second product is treated natural gas. This gas is clean and processed, making it ready for use in home, industry, or for export via pipelines. And the last product is byproducts, such as water, various impurities, which are carefully handled to meet environmental standards. This concludes my presentation. Thank you for listening. I'll be passing the presentation to my group mate, which is Izat.
I will walk you through the core operational process of the Pulse Oil and Gas Company, also known as POGC. POGC plays a central role in managing Iran's upstream and downstream activities, especially in the South Pass gas field. Its operations span the entire gas value chain from the exploration to export and are critical to Iran's strategy energy. Let's begin with the exploration and drilling phase. This is the first stage in natural gas development. POGC conducts geological analysis and seismic surveys to identify gas-rich areas. Once sites are confirmed, drilling operations take place, and both onshore and offshore to extract natural gas and condensate. This sets this sets the foundation for all other processes. Next is the gas extraction and processing. On offshore platforms, separators and scrubbers are used to separate gas from liquids like water and condensates. After separation, the raw gas is transported to a network of subsea and land-based pipelines to onshore processing facilities. This ensures a continuous and efficient flow of unprocessed gas. At the processing plants, gas undergoes refining and treatment. At the one key step is fractionation, where the gas is broken down into different hydrocarbon compounds. Another important step is the removal of impurities such as sulfur, which is handled by sulfur recovery units, and carbon dioxide (CO2). This ensures that the gas meet purity and safety standards before use to export or before use or export. Once treated, the gas move to the liquefaction and storage stage. Here, natural gas is cooled to 162 degrees Celsius to form LNG, liquefied natural gas. This reduces its volume dramatically, making it easier to transport by ship. Gas can also be stored in CNG in bracket compressed natural gas in high pressure tanks or as LNG in cryogenic tanks. These storage facilities are typically located near ports or distribution centers for faster access. As you can see, this is the PNID for the plants, and I want to explain you in the next slide. And now I want to explain about three units in a PNID drawing. Like the previous slide, he has three: Unit 100, Unit 101, and Unit 103. We go to the Unit 100, reception facilities. Unit 100 handles the initial reception and separation of the multi-phase fluid received from offshore production platforms. This fluid typically contains a mix of gas, condensate, and glycol. The main equipment for this unit is a pit receiver to collect cleaning device from pipelines. Inlet separator begins the first phase of separating gas and liquids. Gas condensate glycol splitter further separates the three-phase high pressure separator to provide more refined gas liquid separation. The filters is remove solid particles and impurities. The function is this unit prepare the incoming raw fluid for downstream treatment by splitting into gas, condensate, and glycol steam. And now we go to the next unit is unit 101, gas sweetening. The main equipment for the for the unit 101 is focus on gas preparation, specifically removing acid gases such as hydrogen sulfide as carbon dioxide and CO2. And now we go to the main equipment again is a contactor tower, the main vessel where sour gas is contact with amine solvent, which lean amine exchanges is to recover heat between the incoming rich amine and the outgoing lean amine. Amine pumps and surge drums. This function is a maintain circulation of the amine solution. The function of this is you need use amine absorption to treat the gas. This result is sweet gas, free to H to S and CO2, and which amine which will be regenerate and reuse. Now we go to the next unit is a unit 103 is a condensate stabilization. Unit 103 is responsible for stabilizing the liquid condensate produced from the earlier separation stage. This process ensures the condensate is safe and stable for storage and export. The main equipment for the Unit 103 is a pre-flash drums. Is to remove lighter vapors before stabilization, stabilizer column, to use heat to remove light hydrocarbons from the condensate. Reboiler to supply heat to the stabilizer for vapor separation, condensate surge drum, temporarily store stabilized condensate. Heat exchanger improve energy efficiency by recovering heat. Sour water separator to separate water containing H2S from the process stream. The function is this unit remove volatile lights and separates sour water and ensure the condensate is ready for safe idling and export. As you can see, this is the organization chart of POGC. Now we go to the job scope of POGC. The petroleum or reservoir engineer plays a central role in understanding underground gas reservoir. They analyze historical production data and run simulation models to predict reservoir behavior. Their main goals include: one is developing enhanced gas recovery (EGR) techniques and maintaining reservoir pressure, working closely with geologists and drilling engineers to suggest new well location. And third is providing accurate reservoir performance forecast to support field development planning. Next is the process engineer, who ensure that gas processing units like sweetening, dehydration, and separation run efficiently. Their duties is include designing piping and instrumentation diagram (PNID) and process flow diagram (PFD), adjusting parameters like flow rate, temperature, and pressure to optimize performance, ensuring operation meet environmental regulation, particularly concerning waste and emission. And last is the troubleshooting process issues and recommending design or operational improvement. Mechanical engineers handles the equipment and infrastructure that keep the plant running. Their responsibilities involve is a maintaining piping system, compressors, turbines and pumps, investigating mechanical failure and implementing corrective measure, supervising equipment installation and commissioning, especially on offshore platforms. And last is the preparing maintenance plans and ensuring the availability of spare parts. Now we go to the project manager or offshore supervisor. A project manager or supervisor offshore leads project execution and offshore coordination. Their duties include managing multidisciplinary teams during project development and commissioning, controlling budget, scheduling, and resource allocation, communicating with contractors, suppliers, and government bodies to ensure smooth operation, supervising offshore activities such as drilling, renovation, and emergency readiness. The HSE officer ensures safety and environmental protection, which are crucial in gas operation. Their role involved is designing and enforcing safety procedure, especially where flammable gases are involved, conducting training session, emergency drills, and HSE audit, monitoring incidents near miss and safety hazard, and reporting them, promoting environmental responsibility by reducing waste and emission. Lastly, the geophysicist or exploration specialist supports discovery of new gas reserve. Their role is to analyze seismic data to create accurate geological models, evaluate subsurface structures to identify drilling risks and hydrocarbon presence, recommend exploration targets, and assist in planning evaluation wells, collaborates with exploration teams to assess field potential before development begins. In summary, successful operation of surpass release on a wide range of professionals, from reservoir modeling to safety enforcement, from process optimization to offshore coordination. Each role contributes to the safe, efficient, and sustainable production of natural gas at POGC. Thank you.
Assalamu alaikum and good day to everyone. Today, I'll be walking you through the high level plan for the upcoming refinery plant turnaround project. We'll be looking at the overall timeline and the cost breakdown. Let's begin with the project schedule. As you can see from this Gantt chart, the entire project is scheduled to run from May 25th, 2025 to May 26th, 2026, with a total durations of 204 days. The project is broken down into six key phases. First, the initiation phase, which is the longest, lasting 125 days. This is where we'll handle all the preliminary approvals, scope definitions, and initial setup. This followed by the planning phase, a critical 42 days period dedicated to detailed scheduling, resource allocation, and procurement planning. Next, we move into the executing phase. This is the core of the turnaround, lasting 29 days, where the actual maintenance and upgrade work will be performed. Running concurrently in its final stages is the controlling phase, a short 6-day period focused on monitoring progress and managing any deviations from the plan. After the main work is done, we have the closing phase, which will take 10 days for documentations, final report, and contract closures. Finally, the project concludes with the commissioning and handover phase, a 27 days period uh, to ensure the plan is running safely and efficiently before handing it back to operations. The chart illustrates how these phases are sequenced to ensure a logical and efficient workflow. Refill the Gantt chart at the in the presentation. Now let's turn our attention to the financial breakdown for this project. The total cost for this turnaround is $301,786,000. This slide breaks down how that budget is allocated across the six phases. As you can see from both the table and the pie chart, the two most significant cost centers are the executing phase, which accounts for over 41% of the budget at approximately $132,000. This is expected as it involves the most intensive labor, materials, and equipment usage. The initiation phase is the second largest, taking up 34% of the total cost, which amounts to $109,200,000. This covered the extensive preparatory work required for a project of this scale. The remaining phases have smaller but still crucial. Budget allocation for the planning phase is about 90% of the cost, which is $29,120. For the controlling and commissioning and and hold and over are around 6 to 7% each, which is 6.9 for controlling phase and 6.1 for commissioning and, and over. And the closing phase is the least expensive at just 3.5% of the total budget. This cost distributions aligns with our project timeline, with the most resource-intensive phases commanding the largest share of the budget. So to summarize, we are looking at 204-day project with a budget of just over $300,000. The timeline is heavily weighted towards the initial planning and initiation, while the budget is concentrated in the executions of turnaround. Thank you. We'll pass the presentation to the next presenter.
Hello, my name is Cleanimai. Today I will present about the assessment that we get on our company. For my detail, I will explain the next slide. City is our property during the COPG refinery turnaround. We start with a full HSE plan to protect the people, equipment, and the environment. Some of key safety include the checking for hazard before work start, using OTO to keep equipment safe, and then giving a safety training to all workers, uh, and make sure all everyone use PPE during work. Having has the officer watch over the sector. Before we restart the plane, we do a startup safety review to make sure everything is safe and ready. All of this to help us complete turnaround without any incident. This is a partial assessment that we got on our company. Later, I will explain about all six things that what we got, like hazard, accident that we got, and how to we to manage all these things. As we can see, this is a assessment level. First person is integration puzzle. Assessment most of it we got a 5, and then the other one is we got 4. Most of this work is scope deployment control. We identify the cases we got delay, and then we got over budget. How to manage this thing? How to respond is to stabilize a detailed scope baseline and represent a strict chain control system. This thing can make we got a better plan. And then the second version is planning version. There are 5 activity or tasks that we do during WBS. Most of it we got 3 hires metrics. which is material equipment, materializer, contractor materializers, or modding, and then uh, LTO plannings. And then the yellow one we only get two. And the third one is security Russia, which is we doing 8 tasks. As we can see on the table, almost all of it we got right, high risk matrix, which is executing pressure is almost all of it got some risk, and then the real one we got only two. Next slide is controlling Pasha, which is we only doing one task. As we can see, we got a higher risk during we doing this task, and then the number five is crossing Pasha. Most of it not too danger job. Most of it we do some of documentation or final work or closing, like we doing some paperwork. As we can see on this table, there are 5 tasks that we do. Almost of it we got a medium risk matrix on the four, but on the we also got a green risk matrix. Only one is good thing that we get right now. The last one is combining Pasha, where we can see the is we only doing photos. Like we can see on the table, most of for this task is high risk metrics, where is we doing some of data works. This commissioning version we where we testing the operation to make sure the operation work very well, and only that for me. Thank you.